Are you curious about how to integrate open source, security, and automation? Let's listen to Leonn Paiva of the Brazilian Federal Public Ministry talk about running DevSecOps at the Brazilian Federal Public Ministry exclusively with open source tools. He'll share how they evolved their deployment strategy from a basically manual approach with few automations to a fully automated continuous delivery strategy based on GitLab, Docker, and Kubernetes.
Hi everyone, thank you all for showing up. First, I would like to thank GitLab for the opportunity of sharing this content with you today. It's a pleasure to be here. My name is Leonn Paiva, and I work as a senior software engineer in the government and the private sectors too. My main expertise is in high-performance software development with C++, Python, and Java. It's been a while that I've been focused in cloud, security, and DevOps overall. What I present now is how we run DevSecOps at the Brazilian Federal Public Ministry, and we do it exclusively with open source tools. This talk is not only about how we do it, but it's also about our journey to get where we are now and how we evolve it to the current state. So these are the topics that I will cover to pass on our DevSecOps Flow. First, I will talk about our legacy strategy that sent us back 10 to 5 years, so we can better understand the scenario and pain points that pushed us to our new strategy. This strategy provides us now high availability tools and services for all the country, millions of citizens, 9,000 employees, and more than 1,000 IT professionals today. Then we'll talk about the challenge that we faced with this strategy and how we mitigated and solved them. After that, I will share our results in more detail. In summary, it took around 1.5 years to achieve all that I'm showing to you today, but with a very short but very capable team. By the end of our time together, I will talk about which are our next steps, next challenges, and what we expect in what will come for the future, okay? So about our legacy strategy. Going back a couple of years, our infrastructure was in physical machines, scattered around all the country, and the development teams was also distributed. This led to repetitive efforts, lacks of general management. We couldn't get the things right. We did many things twice, which was bad for us. So later the projects were centralized and only the development stayed distributed. With this change also came the virtualization, so we get better things beside the physical machines. But the way the machines were handled was still the same. For every critical service, a minimal set of virtual machines were established. One for development, one for homologation, and 2 for production. This was our setup for high availability, even in physical machines, and now in the latest days was with virtual machine. Almost every operation was manual: create, setups, updates, maintenance, and deploys, everything. But the infra team was also able to automate some application servers restart like Apache, WebLogic, but was this the most, okay? The most of builds were manual too, but later some devs introduced Jenkins with test and building their pipelines. But this fact was isolated, was an exception. Most of the operations were manual too. And even the deploys were done by developers sending in mail for the infra team with the source code and the path to be overwritten in the servers. The dev team used SVN as version control, but its use was very inefficient. We had a lot of branches, a lot of subdirectories with libraries and dependencies inside it, so the process with SVN was very slow and very faulty. We didn't use tags, merge, was hard to keep maintaining software the way that we were doing in the past. For our most critical system, our build time was between 18 to 25 minutes, with 40 minutes to deploy it with high availability in our infrastructure. And finally, about our security, it was very insufficient and infrequent overall. It was only done once the service becomes available in production or in the internet. It only checked the main URL and the server in the current status, regardless any security outage, system updates over the time. Like 10 years, we didn't have updates in some servers. So this was our scenario. In summary, our legacy exposed problems that we couldn't keep ignoring. The lack of automation in CI/CD, the excessive computer resources spent, which reflects directly in the high costs. This is bad for our government in general, in any sector. Slow development, slow deployment process, and the security vulnerabilities that was saw in many contexts. So our new strategy came up to solve everything. But as a government institution, we must keep always the expenses low. To do this, we focused our strategy in free and open source tools. The main decision was to migrate from SVN to Git, using a self-hosted GitLab Community Edition that can handle up to 1,000 users. This gave us all the tools that we needed to leverage the development and deploy process. To reach out the next level with CI/CD, we migrated from Jenkins to the GitLab CI runner, providing us a fast, smart, and integrated way to do CI/CD to all projects using less computing resources. To use our resources more efficiently and standardize the environments, we came up to Docker. And later, we leveled up again using Kubernetes. Through Ansible, we could get up and running a cluster with high availability in 14 minutes with our Kubernetes clusters. We chose to do it vanilla Kubernetes instead of OpenShift, PKS, IBM, or any other to keep it in a low cost. And almost every functionality that they provide are done with open source, so we can improve and do what they do in matter of time. In terms of security, we added SonarQube to perform static analysis during the pipelines so we can better enforce code quality in multiple languages and spot no security issues before they will reach to production. Also, to improve security, we used Harbor as container registry, as it ensures the artifacts are protected with policy and role-based access control, ensuring that images are scanned and free from vulnerabilities before we deploy it to the Kubernetes. And even after that, we keep securing our images, okay? These were our strategy overall, okay? But only defining it for our organization, a larger organization like us, was not enough. It must be easy to apply, easy to evolve. So how can we do this for many projects, okay? So automation came up to the picture again. We developed two projects to solve that. One to only handle the deploy on Kubernetes. So we have a Kubernetes deploy project, and another called Git Flow that handles all the branching, automatic versioning, test pipelines, and Docker, everything to get to our strategy in an easy way. Basically, the user or someone that will start a new project just has to import the template and use it, and all will be available to the user following our pattern. So these projects, what we should do, it should follow to achieve our DevSecOps flow. Sure, let me change here. Get back 1 second. So when our developers commit and do new features, it only goes to the development and test environment and the branches. After the code passes in a test and quality way, so we can assure that the code is working and everything is good in a minimal way for the development team, testing, and after that for the homologation and production too. So everything must work here. We automatically tag, build, and deploy. After that, we have an action to promote a development tag to production and homologation, and all the process go again, and we can deliver to internet and everything. So what happens when the new feature comes? So the developer commits a code, handle app version here. So the pipelines do a validation that checks the project status, if everything is all right with merge settings, branch settings, variables, everything. If it's okay, the project can run and keep going. So we build. After that, we test. Here we have SonarQube. Here we have unit test. People can add more tests here. And to make the developer life easier, we added a merge request to job that the people can just click play here, and we provided a template that they can use it or use it on other templates that the merge request will be created and then merge it if the pipeline succeeds. Okay, so when the pipeline succeeds, the merge goes to the dev branch and runs everything again with more tests or no, depending on the project or situations, but assuring the minimum quality that we have, building with Docker, automatically tagging the version. We have the version for development with beta, and then deploying it to our servers, okay? What we have here is the same thing that we had for the development. We can promote a tag beta for the master, so it can go to homologation and then production. So we have the project running here in our Kubernetes services, and then we can promote to production. We have here the same flow that can have more tests, more things to test in the production before tag it. But in the way that we deploy, we have a little change here that we enable to. So the tag here is not beta. We handle this automatically too. And then in the deploys thing, we can deploy to Kubernetes. But for mobile projects, we are now allowed to deploy to the stores too. We generate the APK and EPA files for deployment in the stores, and we can automatically deploy to the store, Google Play and Apple Store too. So we have these automations already in place, so can be used for many projects. We have a backend, template, everything that can be used. So which are the risks that we saw in our setup, what we did, okay? We can crash in production very easy because the pipeline was fast. We can do things faster that we can't before. If the tests are not assuring that everything is working, we will crash in production. It's a fact. We will have security issues in the same way. But what we saw after running these many times, if this happens, is because we do not have tests. The process has some failure. So we need to improve that before to keep going more time. We need to solve those things, test, and keep the security and the application working flawlessly. Okay. We saw a lot of problem too. Another risk is the misconception of delivery and deploy. Sometimes we can deploy, but we don't want, or the high management don't want to. They want to deploy in a certain time. So we separated two in this way, so you can deploy scheduled, manual, or automatically. After using these strategies for around a year, we saw many fail points, so we need to improve the monitoring, metrics, logs, so we can know when the issue happened and where it happened. As we're running with Docker and Kubernetes, the containers go and come very fast. If you do not have logs, auditing metrics, we cannot see a problem occurring. The container will restart and the application will keep running, but we will not see any problem at all. Only if the problem keeps occurring multiple times. So those were the risks, but we developed this strategy to solve that too. So which were the challenges that we faced implementing all these strategy? First was the team. We didn't have a large team. Actually, it started with only one person, which was me. Starting this project with Kubernetes, and after that we get another developer summing to the team. And actually today, maintaining all these structure are only 2 people. Okay, but to show you is that you don't need many people to implement a good solution. You need only a capable team, a capable solution too. So after that, we started to solve many more problems. Another one was it was training. We didn't have training. We didn't have people enough to train every development team around the country. So what we did to solve that, we set up lightning talks and small events into the organization to share what we were doing. So every 2 weeks we got lightning talks, 2 hours talks, sharing our main strategy, our migration to Git, using Docker, teaching the teams so they could have a smooth transition. Okay, so this was our strategy. Another thing was resources. We didn't have resources enough for our virtual machines, for our storage to handle all these things. So we couldn't go to cloud, which would be very costly, but we needed to do it in an effective way. What we did was grow in an organic way. We start with little cluster, with little memory, start to grow as much as needed. So when we grow in an application, we start to grow memory, CPU. So we did start small to reach a higher level. Another thing we have is cost. So we couldn't expend much money of the organization. We didn't have. We here in Brazil we have a situation that we must lower the costs even more that we are now. So to do that, we choose it open source, choose it new strategy that could enforce our strategy in a better way. Okay. Another challenge that we had was the process. We couldn't enforce for all the dev teams to use Docker, as they didn't know what it was. Some dev teams, we couldn't enforce using Kubernetes, using GitLab in Git overall. So we started to show the higher management how this works in small teams and growing over the organization, showing results, showing what we could be done and how effective it was, how it could be get a faster development, fast results. So showing this before enforced us give strength to achieve a higher level for our organization. Okay. And the last one was standards. Okay, a team wants to use this, but they don't have enough knowledge in how to do it in Python, in Java, Node.js. So what we did to solve this, we created reference architectures for the people use. We have templates for, okay, how to do a serverless with Python, Kubernetes in our strategy. Here is a demo. How to do it with Spring Boot. Here is a demo. So we have these demos for Java, Python, Spring Boot, Node, and serverless, and many applications that we developed in our organization. So people can see how it's done, use it, improve, and get a new project up and running in these patterns very easily. So about our results, what we achieved with that. Today we have around 210 services in production with this new strategy. With this services now, we saved around 300,000, around 350,000 Brazilian reais. And this low cost was only able because we are using open sources, okay, open software. And this was because we didn't use it provided Kubernetes distributed system. We didn't use a cloud environment. We could use our own infrastructure. So this this saving money is what we need for the government and many companies too. Okay. So we decreased our deploy time by 95%. Our main application was about 40 minutes, and now we can do it deploy in 2 minutes, around 2 minutes and 30. And we deployed many applications in this way already. We decreased it up to 50% of build time using caches and operating in this way. The build time was around 18 minutes, and now is around 9 and 8 minutes using cache and other things. We improved the security using Kubernetes and our setup with SonarQube and Harbor, okay? And now we have a replicable process that everyone in our organization can use it on a small project, big project, old project, and new ones. So this is our main goal, to keep going, keep evolving in many ways, okay? Our next steps that we saw that we need to improve, okay, is alarms. Okay, we have everything running, but we miss alarms. We miss when something bad happens. We miss to know where it happened, how it happens, so we can take an action. So alarms would solve this for us. What we have now, we have Telegram integration, but is a passive way. We must look and see how the thing is going. So we must set alarms that are useful to us. Add log aggregations as the containers go up and down very fast. If we don't have log aggregation, we can't have effective find and discovering the bugs and solving them. We need to amplify and evolve our organizational use. So we have, like I said, 1,000 IT professionals. So we need to amplify the user to all the development teams. So these need to be amplified even more, because today not all development teams are using this strategy. So they are coming up. We are helping them. But as I said, the team is very small. We must handle in step by step. So we need to amplify so we can evolve more. And for the last thing, we need to a good strategy to back up and restore operations overall in containers, Kubernetes. We already have an idea what to use in Kubernetes, Velero, and Kubernetes operators for the containers. So we have an idea where to go, but we didn't start it yet. So these are the next steps for us. So this is what I shared with you today. Thank you for your time. Thank you all. Have a great day, you too.